Hello guys, my name is John Michael Reyes and um, this is I'm gonna teach you about or tutor you about the chapter 3, the network protocols and communications. And as you can see in here, these are the preview of the chapter 3. More and more, it is networks that connect us. People communicate online from everywhere. Conversation in classrooms spills into instant message chat session and online debates controlled at schools. New services are being developed daily to the advantage of the network rather than developing unique and separate system for the delivery. Then then delivery then rather than developing separate system for the delivery of each new services and the network industry as a whole. Then more on, then as you can see, we're just here to understand the network protocols and communication. So let's go to the major parts of it. Now we're back. Then one of the major parts of this chapter 3 is this one, the TCP/IP protocol suites and communication process. Then as you can see in here, we should know that the acronyms and the meanings of this, because this is so important in this chapter, because there are some activities and other stuff that we are gonna answer later. Then as you can see in the application layer, there are DNS. The DNS means the domain name system. It translates domain names such as cisco.com into IP addresses. IP addresses are the numerical numbers like the 192.168.3.1 and other stuff. There are so many IP address that you can make. Then the bootstrap protocol or the bootstrap protocol is somewhat enable this workstation to discover its own IP. The IP address of a bootp server on the network and a file to be loaded into the memory to boot the machine. Then bootp is a superseded by TCP, the DHCP then DHCP or dynamic host configuration protocol. It is what we always use in our activity in packet tracer, skill exams, skill integration, and other stuff. Then dynamic host configuration protocols is somewhat dynamically assigns IP address to client station at startup, then allows the address to be reused when no longer needed. Then SMTP or simple mail transfer protocol enable clients to send email to a mail server, then enable server to send email to other servers. Then the POP or the post office protocol version 3, POP3, then enables client to retrieve email from a mail server, then downloads email from the mail server to the desktop. Then internet message access protocol, it is somewhat just like the other two. It enables client to access email store on a mail server, then maintains the email on the server. Then the FTP or the file transfer protocol, it is somewhat a reliable, connection oriented, and acknowledged file delivery protocol. That is one of the major description that you need to have in the FTP. Then TFTP or the trivial file transfer protocol, just like the FTP, but somewhat less because it has a less overhead than FTP. Then the web or the HTTP or the hypertext transfer protocol, it is somewhat, we all know that because it is somewhat exchanging text, graphic images, sounds, videos, and other stuff. Then in the transport layer, the UDP or user datagram protocol, it is somewhat less overhead, faster than TCP, and it is used for streaming and other stuff. Then TCP is somewhat a reliable in sending. You need that in order it resent all the missing segments and other stuff. You need that in sending some Gmails, emails, or in other web applications. Sorry for that, I'm pretty exhausted. Then the internet or the IP or internet protocol, it packages message into packets. Then NAT or network address translation, translate IP address from a private network into globally unique public IP addresses. Then ICMP or internet control, then OSFPF, then the open shortest path first, then the enhanced interior gateway routing protocol, the Cisco proprietary routing protocol, then ARP or the address resolution protocol, then the PPP or point-to-point protocol, Ethernet, and the interface driver. Then the next one would be TCP/IP communication. As you can see in here, there would be someone sending, then the data IP, then the other one would be just like that. Then as you can see in here, there are process and other stuff. Then in here, as I've said earlier, there are some activities in here, so let's try to answer this. First is the network access. We all know that the network access would be the interface driver and the Ethernet. We all know that because of the trivia or the things that we know in that. Then the transport protocol is somewhat the UDP and TCP. UDP, let's find the UDP. Where are you? Or the user datagram protocol, and the TCP or the transfer protocol. Where's the TCP? Where are you? TCP. Then in the internet is somewhat the IP. Then the somewhat the open shortest. Then airgap. Then other stuff just like INAT. I think it's. But first, let's go for the application layer, the DNS or the domain name system, then the POP or the post office, then SMP or the simple mail transfer protocol, then the IMAP or the instant IMAP is somewhat internet message access protocol, then HTTP, the hypertext transfer protocol, or then DHCP or dynamic host configuration protocol, then the ICMP, and somewhat the TCP. Then I think the ICMP is somewhat not in here because it should be in the internet, so the boot P is in here. Then let's check. As you can see, all the answers are correct, and let's proceed to another major topic. Hi guys, then I'm back. This is the second of the most major content that in chapter 3 is in it, the OSI reference model. As you can see, the application layer. Application contains the use process of communication, application. Then we have the presentation. Presentation is a layer is provides for common representation of data bits transferred, then the session, then transport, then in transport layer defines the segment, then other stuff, then it resembles and the data for individual, then the network layer provides services to exchange the individual piece of data over the network, then data link. The data link is layer protocol described method for exchanging data frames. Then physical is somewhat just the bit and mechanical electrical functions. Then TCP IP protocol model, as you can see in here, application represent data to the user plus encoding and dialog control. Then after that is support communication between various devices across diverse networks, determine the best path through networks, then control the hardware and make up. Then next, then as you can see in here, comparison. As you can see, the OSI model and the TCP IP model. The OSI model is somewhat more specific than the TCP is more general. Then activity, and as you can see, there's another activity in here. Then the activity is somewhat all about the OSI layer. Then segments are bits transmission, that would be physical, I think. Then provides data path or route. Frames data path or route is somewhat network. Then frames between devices, it's somewhat the transport is for the segments, then the exchange frame between devices is this one. Contains protocol used for process. I think this one and this one. Then as you can see, all our answers are correct because it is somewhat in the description of the other two. Then this first one, then represent data user control determine the best path. In order, the one that determines the best path is somewhat the internet. Then data users individual dialogue support communication across diverse network. Somewhat controls hardware and media. It is somewhat the application. Then this one would be the presented to the user. I think it's the application is here. Then transport is support the communications. Then the network would be this one. And as you can see, all of our answers are correct. And let's proceed to another major topic. Then we are back. Then as you can see, we are here in the third part, or the third major part of the chapter 3. That is the protocol data unit. Then as you can see in here, these are the, as you can see, let's provide meaning in this. The data, the general term for the PDU used at the application layer. Then the segment is somewhat the transport layer of the PDU. Then the packet is the network layer PDU. Then frame is the data link PDU. Then the bits is the physical layer PDU or bits. Then and the other stuff. Then let's proceed. Encapsulation example. Encapsulate data, then TCP, then IP, then Ethernet. Then it converts to a binary code. Then decapsulating, this one is somewhat, as you can see, in decapsulating, it would go to Ethernet, IP, then TCP, the IP packet, then it will be go into the TCP segment, then user data. Then you can view that in the host or another PC. Then activity, as you can see in the activity where we have in here, then email. Then first of all we have the data, that would be, then segments. After the segments there would be packets, then after the packets frames. Then as we all know, bits are the last, so let's check. As you can see, it's all correct, and I think that's the last major activity of this chapter 3, and that's all.